All right, it's 4:05. Let's kick this party up. Today we're going to have our second meetup of the year. The last meetup was a smashing success, and the speakers assembled for today, I'm sure will do a great job teaching us how to build local first apps. Our focus is trying to go a lot more aligned with product developers and builders who want to use local first apps, and we want to make sure that's as easy as possible. Community update wise, there is a survey out in the announcements channel. Please fill in this survey so we get a feel for the community and we can do a better job serving you. One of the most important questions for me is the time zone, so we can pick the next meetup to be equitable for everybody living in different countries across the globe. We have people in Southeast Asia, Australia, you name it, and love to have a middle ground for the hours. Next thing is Lewis is championing book club. Look out for that channel. The next meeting session will happen next week on Tuesday, and I'll let Lewis share a few more details about that. So, our first talk is Local First in the Wild, and I'll kick it off to Grant.
All right. Hey, everybody.
Hello,
So
hello.
I made a local first grocery app called Cookie.club. And this talk is basically just kind of rambling about my experience with that. Some things I learned, some trade-offs I made, the constraints that I put myself under to do that, and how they helped, I think, ultimately create a great product that I'm very proud of. So I didn't really start with local first. I started with a set of constraints. In fact, I didn't really know the term local first when I started this project. But what I did want to do is learn a lot from my experience in a very early stage startup in the venture capital world. And I wanted to kind of 180 that. Like, I really wanted to try to bootstrap something, slow growth, sustainable software. It's something that I'm becoming very passionate about. And part of that is extreme frugality. One of the main points I wanted to hit was that free users shouldn't cost me anything. And this is actually what led me to Local First. For me, it's like if I want to create something sustainable that builds up over time, that I'm the sole founder of and worker on in my free time, having users that are just free trying out the product, assuming I succeed, like I would get a lot of those. And if they cost me money, that would be a really big financial stress on me being able to bootstrap my product. So that was one of the constraints I tried to put myself under. Another one is that cost growth should follow revenue growth. So this was basically means that if the app costs me more to run, that should be following the app bringing in more money to help me run it. So I don't want costs to start to outpace the amount of money that's coming in. These both kind of tied into local first, and I'll talk a little bit about how that ended up working out for me, or hopefully will work out for me. It's still pretty early days. I also wanted to future proof. So as I began to look into local first, a lot of the existing solutions gave me some anxiety, mostly around schema migration is something that I'm very familiar with doing in a traditional app. But I didn't see, at the time that I was looking, I didn't see many clear paths to do it with local first technologies in the web. And then storage compression. So a lot of current like CRDTs basically store all of history, but that also gave me some anxiety because devices have storage limits. And in general, that just seemed like a ticking time bomb. So I wanted to kind of push myself and see if I could overcome that obstacle as well. The biggest constraint that I was facing was that I had 3 months basically to do this. I had a really unique situation where I had a break in work. So my responsibilities went pretty far down. And then looming here in 2023, I was about to become a father and I was about to start a new job. And so I was like, all right, these 3 months, this is when I got to make it happen. So I had no intention of making a generalized sync library, but I did. So I created Lo.Fi in part because, so I thought that a grocery list, like, right, that's pretty simple. It's a list of things. I can probably get away, just with hand rolling some simple CRDTs or not even worrying about conflicts, but just kind of like figuring it out as I go. But it turns out all of the features I have listed here, I ended up using in this app because I just got so like, I had so much fun making it that I wanted to make all these production quality, like interesting features. And so I just kept building, and I ended up with Lo.Fi. And it's worked really well for me. And I'll talk a little bit about how that's come into play. Yeah, it did work. So I came out with an app that I'm pretty proud of. As you can see, it looks like a real app. There's no like, I was very adamant about trying not to expose any technical choices as trade-offs for the user, but to give the user the kind of experience that they expect from any app that they use, web or not, and see how much I could power that with local first. So in order to get there, I had to make some compromises. One of those compromises was not doing enough of my homework. Like I said, I had 3 months, and this space is still pretty new in the web and still evolving. So, there's tons of amazing blog posts, tutorials, there's breakdowns of how CRDTs work. There's everything on Ink and Switch, which is just amazing. But I didn't have time to read all that, and I definitely didn't have time to absorb and understand it. I really wanted to build fast. And so I did not learn the lessons. And that I think is one of the most fun things about this project, because I ended up making a lot of assumptions. So when I built Lo.Fi, I made a lot of heuristics, and I chose heuristics over rigorous correctness. For example, if a replica, like you have multiple replicas all syncing together, they can all make offline changes. But if a replica has offline changes but hasn't been seen in 10 days, basically just kick it out. I'm like, okay, you can come back with your offline changes, but I'm not going to accept them. You have to sync back to the baseline, and your changes are forfeit. Now, for a lot of app types, this would not fly. And there are a lot of more correct solutions to this. But for my purposes, it actually worked just fine. This is a grocery app, so ideally you're opening it at least once a week. And those constraints work well for me. Or say like deletion stuff. If you delete something and 3 days pass, I just assume you're not going to undo that. You're not digging back in the history of your grocery list, right? Um, so a lot of these constraints I was able to place on myself because I just assumed that I was the only person that was going to be using this library. Like, yes, I publish it to npm and all that stuff, but like I made a very conscious choice of, oh, let's not count on anyone else ever needing this. I'm just going to build it for my case, and that turns out to be a really great way to ship products. The wins, I think, were worth the trade-offs that I made. One of my favorite wins was just learning how to use local first and getting that experience. Uh, and local only was a great thing to come out of that. So I talked about how I want free users to cost me basically nothing. Free users never touch my server. They fetch the initial web code and they download the app. And the browser is an amazing software delivery platform. It's not really what it's designed for, but you put a service worker in there and you cache all the local files, and your user just has the app the moment they visit your website. It's amazing. And they get to use that for free on their device. They get to try out almost every feature because almost every feature works offline. Um, and that's great. I can keep supporting that forever because it only costs as much as a domain name per year. And that makes me feel good because my work is going to live on at least in some form, even if I have to shut the server down due to costs. And my server can go down, and I don't have to worry about it too much. Still want to figure it out eventually, but at least you can still open the app. Another win that I got was that good enough that I was talking about really paid off for me, I think. So this is probably looks pretty complicated, but this is my very simple migration algorithm. So I'll briefly run through this. I don't want to spend too much time on it, but if we have two replicas that are both on version 1, and let's say they're both offline, replica A makes a few changes offline in version 1, and then it goes online and sees that version 2 is available. So it's going to make A 1.5, which is a migration change, where it converts all of its data structures to the new format and the new schema. And then it's going to continue on making changes in version 2 in the new world. Replica B was offline further, though. So they were offline for more time. They made more changes in version 1. Then they made their migration change and got up to version 2 when they came back online to sync. The final timeline actually sorts everything in version 1 in the past, even if it was logically like wall clock time, even if it was in the future. It puts all of the migration changes together in their own little time bucket, and then it puts all of version 2 in the future from there. This is super naive. I would not write an academic paper on this, but I did write a blog post on it because it was enough for me to ship a product. There is definitely places where you can lose data from this. It's a little risky, but migrations don't happen that often. And so from a very practical standpoint, I was like, yeah, like Cambria is amazing and like I would love to use it. But for the purposes of shipping in 3 months, I'm just going to go with this and see how it works. And it did. It was good enough, at least for my grocery app. Another thing was that deletion paid off. I mentioned not wanting to have storage continually scale up over time, but to be able to actually delete things from history and for them to be permanently gone. It's kind of something I wasn't able to find a lot of documentation or research on in CRDTs. I'm sure there's research on it, but again, I didn't have time to read it. So I did kind of my own thing. I used IndexedDB, so it's basically a document-based database. So here we have a recipe that has a title, which is a primitive field, so it just gets attached directly. But it has a link to ingredients, which is a list, which is a different object in the database. And that just kind of continues on. They're all just kind of like loosely linked by IDs. But that means that a file handle is also an object. And a file handle points to a file that's somewhere else in the system. All my files are actually stored in S3 on my server, kind of traditional like that. They're also cached locally on your device. But the files are in like a separate subsystem from the main CRDTs. So I wanted a way that I can be sure that a file is completely deleted from the CRDT side so that I can clean it up on my side and reduce my storage costs. And I was able to do that because I had thought, okay, I want to be able to delete things for real. I could just hook into that event, notice when the file handle was deleted, and schedule a task to clean up the file out of S3, which means that my storage costs are not monotonically increasing over time because I have to keep all those files around because history is forever. But since history is not forever for Lo.Fi, I can go ahead and delete those at some point and save myself a little bit of cost over time, which may end up adding up, may not. I may have done a bunch of work for nothing, but it was fun to figure out anyway. And then I can't really talk about local first without talking about how fun it is to write. This is all the code I needed to add images to recipes, which was just mind-blowing to me. I got to just set the file on the object synchronously as if it was any other data type, and then it gets synced to my server, and then synced to any other clients that are connected to that library. It's just, I can't even overstate that there's something magical about building with local first. So the last thing I want to talk about is the business side of things. I mentioned it and alluded to it a few times. And I wouldn't really call myself like a business guy. Like the aesthetics of business and like profits and revenue and costs, they don't really like match me, but it's still something I found is important to think about as I'm considering bootstrapping and making sustainable, ethical software. It's worth thinking about this stuff because otherwise you get caught in some weird bad cycles. I noticed this with the startup world because I'm really passionate about direct to consumer apps. And in the startup world, especially venture funding, it like feels very dead end right now. Users don't like paying for things. Just like your average, like my mom does not like paying for software. Um, so like in order to get them on the software, you either need to offer it for free and then find some way to recoup costs, i.e. exploiting them in some way. Or you can write out other people's money, i.e. venture funding, and then look for an exit, which usually leads to selling to someone who is going to exploit their data. That doesn't really sit well with me, but I did want to see if I can make enough profit eventually to survive just on building consumer apps. And that means surviving on $4 a month subscriptions after Stripe fees. So the frugality comes in, but then also like local first itself just felt like a godsend. I was like, this makes sense to me. Like using the user's device, allowing them to store their own data, allowing them to use it for free on their device without even touching my servers. I feel like this could actually work. So that's what really got me excited about it. The last thing I'll say about the business stuff, when I'm talking about profits, revenue, like I said, the aesthetics of that, I'm not really fond of. But I really started to think about it in two different ways. There's the guy on the left who is scaling up the business and wants the line to go up and is really focused on the metrics. That's not really the guy that I want to be. But then there's the guy on the right who is just trying to deliver a great local product. And that's kind of where I want to go. And the guy on the right still has to think about this stuff, like still have to make sure revenue is enough to keep the business open. But it's a different vibe, right? So I want to be more of an internet small business. And that is one of the reasons I'm excited about Local First. So that's all I got to say. Check out Noki.club. Lo.Fi is up there too. Here's my cat. And thanks.
Wonderful talk, Grant. I definitely dig the get paid enough so you can just build whatever you want and ship features for users. That's a big goal for my life as well. I'm a avid subscriber of uh, indie hackers. Oh my gosh, I lost the site, but it's like it's one of those where everybody who just made X amount a month to survive just posts their startups, their story, and I love reading about those. And hopefully, you'll be able to hit that target so you can sustainably keep building us amazing software. Next up, we have a talk by Horatio. He's going to break it down for us on how exactly you can build collaborative web applications. And we'll kick it off to him without further ado. Horatio.
Hello, everyone. Can everyone hear me well?
Yep, we can hear you and see
Yes.
you.
Okay. So I cannot see anyone. Well, that's fine. Well, thank you, everyone. How much time do I have? Like 10 minutes, 15 minutes,
Yeah,
10
10 to
minutes?
15 each,
Okay,
however you
that's
need
all
to.
right. Good. Okay, so yeah, I'm Horacio. I'm a designer, developer, building this application called Meter. Like yeah, that introduction was too broad and too much that I wanted to do, but that's fine. I'm actually just a very humble like opinion on how people can collaborate and can how can we help people create better and do better collaborations using P2P and local first software. So I did this like bullet point thing so I can just follow a little bit on what I wanted to do, and then I'm gonna show you a little bit what the app is and how it looks and how it should work. So the main thing is that we wanted to we are in a publication deliberation and publishing crisis right now in the internet because we have a lot of data silos. We have this like big corporations that they control all the data and they control how we consume the data also, which is kind of scary. And we are getting into this new era of new digital tools that get rid of these things that and this control that this big media or big corporations like to put in place, right? So and we what we really want, and I personally really want this, is to give people choice, the choice to do whatever they want, and also to share knowledge, keeping attribution to people. And we started with this naive idea of, okay, I don't know if you heard about this, the internet, the digital scene, the original scene, sorry, from the web, but essentially it's just a way it led us to what we have right now, which is an internet that is controlled by ads and by keeping you doom scrolling and keeping you finding information in this like massive like floods of data. And we found the answers like 50 years ago with our three founding fathers, which are Vannevar Bush, Douglas Engelbart, and Ted Nelson. I'm sure to some of you, like those names like pops up. And essentially, we believe that with the things that they created and the technology and the information that they shared, we are now in a time that the technology can enable this type of technology in a good way, in a permissionless way, right? So essentially, those are like for us is decentralization, view specs, authorship, and micropayments. So decentralization, because that will give us the ability to connect and to create and get the information that we really want. And we are seeing that with other like type of social networks and applications like the elephant one, that one, uh, that I don't remember the name because I'm Mastodon. There you go. Thank you very much. Also, view specs. A little of detail about what view specs is. It's actually the ability for readers or people that are consuming data to rearrange or restructure the data as they please or as they need to. Right now, and this is I mentioned before, the doom scrolling, the way that we're consuming data, for example, in social networks like Twitter and all that, is by scrolling and trying to find something meaningful over there. And the amount of time that we're losing on that is massive. So view specs are four different like features that let you organize information, structure the information in a way that it's trying to avoid this type of behaviors, right? Authorship is one of the things that we are really passionate about, which is every content or every data that you share or you post or you publish should be digitally signed by your identity or your IDs. And this helps also to not only discover more information, but also follow trails and find more useful data for whatever you're trying to to do. And micropayments is just like the extra sauce, and maybe it's also something that can help remove this original sin from the web, which is a way and something that it was thought from 50 years ago too, and when the web was starting, the way that you can actually attribute a value in a monetary way in this case to the creators, that the people that actually create the information, not not the people that control the platform, right? So we started with this idea. We wanted to okay, we were thinking first, okay, we're building a second web or web 4, web 5, I don't know which web we are in right now. But then we said, okay, no, like the web is the hypertext system that we all have, and it's not going to be anywhere. So the it's going to be very, like, it's a naive approach to think of that we're going to replace the web. We just want to enable decentralized collaboration in the web. So, and this is done by creating an open hypermedia database and attaching authorship to the data or authenticated data, creating a system that can do backlinks management, like also like work in a peer-to-peer setting, which enables people to connect with the peers that they really want, so they can consume the data that they are really interested in. A version control system, which is something that because we are in a decentralized setting and working with peer to peer, ways to, like, concurrent changes are going to come. So a way to gracefully follow the history of all the changes is very important. And again, because everything is digitally signed and we have identities attached to data, we can also add royalties to information, right? So, um, like just like TLDR from here, we started with a way, okay, let's try to bring more value to creators in the web. And now we are in a place that, okay, we want to enhance the hypertext system that we have, which is the web. And how we're going to enhance it, trying to help people build tools to create better collaboration or collaborate in a better way. One little detail compared to other like applications that you may seen, and also this is very common. When you think about collaboration, you usually think of real-time collaboration, and this is one of the trade-offs that we did. We're actually not focusing right now on real-time collaboration. We're focusing on asynchronous collaboration and permissionless collaboration, which means that you can actually see all the changes that any data can happen, any data would have, and then you can rearrange, connect, add, delete, whatever you really want. So let's jump into the app. Let me just go to an empty screen, not this one, but that one. I was actually taking some notes here. But so here you see that this is the actual document that we were seeing before in the website. I created this document in the Minter application, which is this one. And you can see that it's disclaimer. This is very, very alpha. So I'm crossing my fingers that nothing like breaks and nothing explodes. So you can see that here you have some information about this publication that is signed by my identity, which is right now Horacio Demo. This is my the profile of my identity. And then you can see that we have multiple versions of this document that is immutable. There's no way that if I have the IDs or the IDs of this document, there's no way we can change that. And I'm going to show you why. So I can go to all the versions of the document. I can see how everything changes, and then I can also do commenting on top of data. So I can select any piece of data and I can write, this is a demo day, and I can just do that. And I can see all the comments also here, and they're like distributed peer to peer with all the peers that I'm connected to. And of course, you can reply. Good one. And is everything also shared between the network? I don't need to be online to do all those things. The application also works local only. And when you connect to the network, then it's going to be connected to other peers and announce all the changes. So I mentioned that we can edit. So yes, if I click edit and then I add another stuff, I can keep adding those things, and then I just create a new version, which I need to reload, and then I see it here. So yeah, then the immutability of these documents is important because we can not only author data, but we can also reuse data from other people. So I can just go here, no, not exactly here, but here, and you see that I have this little like text here, which is like highlighting in a different way, and we call it a transclusion. I'm sure somebody like other people have heard about transclusion before. And one thing that we are also enforcing is the way that you can have you can have visible connections between data. So you can see that whenever I highlight it here, I know that the source is inside this document and the way back too. So we have bidirectional linking around all the data that we are using in Minter. And this is important because I can know that this piece of text, for example, in this case, of course, I already authored both. But if I reuse some piece of data from other people, from another user, I can know when I render or when I ask for this information, the amount of data that the other author actually like contributes. And we can have a very good detail of the distribution of all the contributions of each documentation or of each document, which is really nice and it's really good because imagine you can have a micropayment infrastructure that you can also, whenever someone pays for this document or whenever someone tips this content, we can redistribute the payment to all the contributors of that one document, right? This is one of the powers. And then the other thing that we are also adding is the ability for you to publish this document. You're here now in the peer-to-peer world, but then you want to publish this to the world, and you want anyone, not only Minter users, to see your content. And that's where the website comes in. You can actually connect sites to your publications and to your documents, and you can publish versions of your data, and people can actually here see all the information. They can also give you attribution for this information. This is not ready yet, ready yet, but this is something that is coming pretty soon. And essentially, like with these properties, which is decentralization, peer-to-peer, authorship, and a way to attribute value to people, we believe that we are going to help create and share more knowledge, and help people, creators, get the value that they're actually putting out there. So yeah, this is essentially it.
Awesome, thanks. Let's start my. Hey everyone. Let's. Perfect. Then let's go. My talk. Okay, so we are at local first web apps. So I'm gonna focus on web technology and on um, some constraints that are a bit different from the speakers before. And I think it's also interesting that we focus first to look at what kinds of constraints we have and then what kinds of solutions we come up with. Um, it's interesting that we see that local first apps are not a unified space of how to build applications, but are really fractured into many little individual ways to build, and every aspect has its own trade-offs and um, a lot of cross-pollination, of course, but it's always important to look into the details. And yeah, I like that. So I built offline first, local first applications for 10 years. Um, I mostly work on productivity and communication tools. Think email clients to do customer support, things like that. I worked for eHealth Africa before, where we were working on Ebola control and also on vaccination dashboards that were running with offline tablets and offline phones with health workers that needed to sync. Eventually, when they had internet and people really going through Africa on motorbikes and things like that. And also, I worked on a multi-messenger called Flux, where you could sync in like Facebook Messenger and emails and things like that. And messengers are also um, pretty core application for these kind of local first applications, because you can't wait for your messages when you read them, and you need to send a message and the phone needs to be shut off, and then eventually when you have internet it's going to sync. There's a great blog post also and a podcast about how Facebook Messenger was rebuilt, and all these messenger applications come to these kind of same problems and same kind of solutions in the end. So let's zoom in what I talk about. So of course we looked at text collaboration, whiteboards, and multi-player kind of applications, which is not what I'm talking about today. So these are all things that need to sync and need to have a really live and high volume sync, and also where it's more important to get consistent to the same state than it is to not lose any details. especially like multiplayer things. It's not so important to have the cursor in Figma not be perfect, or the path of the cursor not being perfect. So it's far more important to yeah, just be live. And I'm talking about personal data-centric applications, which is everything. Think of all your PIM tools and things like that. So to-dos, notes, email, messaging, banking, um, health data, calendar. So things where you have some collaboration, but not so much collaboration on the same documents. Like you, of course, you need to sync with your colleagues, your calendar and things like that, and you need to have your messaging, but you rarely edit the same concrete email with your colleagues. You rarely edit the same calendar entry at the same time. It happens, but it happens maybe a few times a day max. So it's not this live text collaboration kind of live. So that brings us to our constraints for now, which is a web text. So um, there's great offline first, local first applications like Obsidian with files on the system and with full applications. But those are just a different approach for different kinds of solutions. It's great for nodes, of course, and it's great for everything that you can sync through Git. So I would say everything that can be done in Git with such an approach is really, really well in such a system. Of course, open source, because the original philosophy also of these offline first applications was always to sync data and sync the application itself, and also added a local version and work on the whole system data, including the application itself. So I think it's an important part of yeah, of the philosophy, but it's also possible to have some business. Obsidian is a good example, and there's also many ideas for server sync that can make money. As I said, no data loss and important merge inconsistencies. So there's a whole class of automatic merge and CRDTs that work more on these kind of applications that I talked before, but are not so interesting for this personal data-centric applications as I defined them. Some more constraints is it needs to quickly open a new browser, and you need to be able to make it as much offline as needed in your concrete application situation. And it needs to support not just the naive case where you have maybe all your data in a local storage in your browser or something, but it needs to also work for much bigger data that you cannot have all on your machine, either because it's too big or because the replication, the initial sync will take too long. So you need to open it quick in a new browser, work, have everything offline that you worked on, close the client, and open it later, and be able to replicate without having these big headaches. Real-time and UI sync is part of the experience. Of course, if you have it's interesting that this real-time UI and sync and reactive UIs are connected to this whole offline movement, but I think the reason is because when you have potentially conflicts in the background, of course you need to have your UI show you who else works on something in this exact same time, and also show you some real feedback from other clients. So it's kind of not obvious, but if you look into it, it's always connected to have both aspects of this exciting UX. One other constraint is it's quite simple, or not simple, but it's possible to have a lot of problems resolved by having always the concept of a central server who decides, and there's things like replicache and some solutions that make use of that, but this is a bit too limiting for me, especially if you are looking into, let's say, situations where you have two phones that need to sync or something like that, without having maybe access to an internet. We had this concept of replication parties where people met developing in the woods without internet, just trying to have these ad hoc networks. And there's many interesting things that come out of multi-master support. And lastly, I think it's important, especially because not a lot of clients maybe will support spending a lot of resources on some using some framework that is only offline first. So it's important that a system that we build can also take advantage of the side effects of having this architecture for a normal web application, just by making the latency really nice because you have stuff on your device, and having high resilience. So I think it's important to be flexible how much classical and how much cutting edge architecture you want to use. The first component to build such a system I wanted to talk about is service workers, because I think they are still not used widely enough, and I think they have a central role in web applications going forward even more. We talk about edge, but if you think about edge computing taken to the max, it means running on your device, and this is exactly what a service worker brings. It can serve like a little server on your machine, serving multiple browser tabs. It can keep sending a message in the background when your tab is closed. It can get notifications and messages when you're back online and things like that, even if your browsers, the browser tabs are closed. It has advantages because it automatically terminates and restarts when it's needed, so you don't have to really take care of as much to make sure the user's resources are taken advantage of, because it will terminate and restart. So it's always it needs to be able to run stateless and just use caching. And also there's now things like Cloudflare workers or Cloudflare worker daemon that are compatible to service workers but run on the other edge, so on a CDN or something like this. So it really gives flexibility to think about an internet computer, so to speak, that consists of edge, point of presence, and your devices. And also a nice side effect is it runs in a different thread, so your tabs are free to render the UI at 60 frames per second. And so I want to coin this term more service worker first development, which means whatever you can do in the service worker that makes sense, you do there first. And you move it to either the Cloudflare edge or something like that, or to your browser tab only when you need into either direction. So it's like the good space in between. Then we have some runtime. Now we need some data layer that is at the core of everything. Data layer is usually quite complex, taking care of a lot of things. And things like caching, request batching, invalidation, and optional validation, stitching different data sources together, and abstracting things like service architectures from the application and UI layer. So many of those needs. And there's so far usually something that you do either manually or with something like GraphQL or things like that. But I want to also show a bit forgotten technology called Falco from Netflix. And I will show roughly how it works and then how it's used better and why it was forgotten a bit. So first of all, it's schemaless. Unlike GraphQL, you don't need to write your schema. You don't have like a concept of a query with a lot of features like in GraphQL. It maps to mostly JavaScript object actions, so it's really close to what all the UI frameworks support. And it doesn't have a complex query string parsing or things like that. And so it's quite easy to reason about and has a very focused responsibilities. And it is also simple enough to run in a service worker. So Falco was originally thought of to run on a server, but I run this in a service worker because we have no server in this world. And of course, it can forward things to an edge worker for things like the synchronization with other clients and things like that. Um, but it doesn't have to. So it has this concept of a source chain of data sources or a fallback data source, so it can answer everything that it can in the service worker locally on your machine and then forward things it can't answer to an external HTTP data source or something like that. And it has the concept of this caching and invalidation. So either you can have keys that expire and then just refetched from some other source, or you have imperative invalidation where you just call invalidation. So it's very close to JavaScript. So the first example, like you all are used to just accessing JavaScript JSON data with dot notation, and in Falco, instead of having a local object, you forward basically to a model that's from a data source, and you can have a chain of sources, and you access them as similar to the standard object access as possible. And the big difference is in Falco, you need to use a method and it's asynchronous. So yeah, that's the big difference. But apart from that, they try to be as close. And then how are these data sources answered? They have like a virtual object that looks like your placeholder data object maybe, and they are answered by a router that works similar to your browser router, just it works on JSON path expressions. So you have like a root handler for name, surname, address in this case, and it has a function that gets the data and answers this, and this router runs in the service worker. The problem, and one of the reasons why it didn't catch on, is that how would you then hook this up to your UI layer? In practice, you have like a placeholder and oh, someone's posting my screenshots. Oh, okay. So some people cannot see my screen, but some can. I will. Okay, I will try stopping and restarting. So me, it works now. Is it better for people? Okay, that's good. Good. I had the chat in the background. So the problem is that in the end, because there's not really a great way so far to hook this up to your UI layer, what happens is you have like a on mount function in your components, and then you have all these path expressions that you need to preload. And then people started writing something that makes this look like an object, and then you have something like GraphQL on the end, just without a lot of the features of GraphQL. So people started using GraphQL instead. But the big killer application for FileCore that I want to introduce now is to use it together with an ECMAScript proxy. So it's basically a virtual JavaScript object that you can have traps in that basically call functions on all the access that happen to these virtual objects. They are originally used just with one level of nesting, and they used to have like a real object that they encapsulate. But in my library that I built for proxies, they don't have an actual target. They just are completely virtual, and they also are deep. So they always return another proxy, so you can have any number of nesting without having access to undefined errors or anything like that. And basically, they support all the standard things. So if you just log to the console like a level 1, level 2, that you will have maybe a log or a function called get action on this JavaScript JSON path. If you set a nested thing, then you will have a set to value action. And if you call a function, you have a call trap basically. And it turns out that this is basically exactly what router paths look like. So you can hook up this ECMAScript proxy to the file core and then avoid all this boilerplate. And basically, you just have a a normal access to like you would to any object, but it forwards to your service worker, and this runs all your Falco routes. And inside of this, basically, I run the PouchDB, which is in-browser JSON document store, which with revision numbers and changes feed. So we have another talk next or the meeting after about some concrete conflict resolution strategies and data modeling. So this is not part of this talk, but it's basically you store JSON documents in IndexedDB, and every document has a revision number that counts up. And if there's a conflict, your application layer needs to resolve this conflict, so it doesn't do any of this automatic things. So we talk next time or when we have the session about how this exactly works. What's important is that it syncs with a CouchDB server, and that it basically has a changes feed with everything that changes, which can then trigger these invalidations to Falco and can trigger this live UI. And a quick demo, because we're running out of time. So here we have a simple to-do application. Basically, you see the requests to Falcor look like requests in your log of the server, just that it's expressions that go to a JavaScript object. So it's like JSON path expressions. And if I add to do, you see the sync request with a sequence number that counts up and gets the change and invalidates basically the UI, which then fetches from the service worker. So if I have a new tab, and you see that it syncs, and also when I have a view that's dependent on some other view, and I, for example, unmarked as done something, it also goes into the reference, and it knows where something was rendered and can also update views that are not the same. And Yeah, so it's all in IndexedDB and the service worker. I think that's as much demo as we can do right now. And to end, maybe an outlook and a quick overview of the architecture. So first of all, this is basically what I just talked about. We have the browser and the tabs and the service worker with running the PouchDB, the router, and the replication. And you in tab, you have the JavaScript proxy, in this case with the Svelte store that's accessing this for the UI and the Falco model and cache. And you have the sync with the CouchDB. And then the last thing is that it's important to have also accounts that support this model. So for example, you need to expose that you have data stored on your device and how much, and you have to expose, can you delete your local data? So in this case, I exposed that there are 5 unsynced changes that would be lost if something is deleted, and how much is synced. And these accounts need to be able to access without logging in. So the login is more or less to sync to an external server. So you log into the sync process, but you can always just create an application that's offline, no login, no account creation, it's free. So that's mostly the quick overview, and now I'm happy to answer any questions.